Awesome. Well, thanks for everyone for joining. I'm going to record this and we'll speak for about 30 minutes and then do a 15-minute Q&A. We'll enable folks to unmute and just use the raise the hand button. But quick introductions and thanks to Andy and Jordan for joining. So Andy, I'll maybe start with you. Andy's associate professor of databaseology in the computer science department at Carnegie Mellon University, both a member of the database group and the parallel lab group, very frequent lecturer, paper author. Bunch of his students kind of have gone on to pretty amazing database management system companies. He's also the co-founder and CEO of OtterTune, where I have the privilege of working with him and his co-founders, Dana and Bohan, which is an AI-powered database tuning and optimization company. Lastly, I would can't not say that he's the head of OtterTune Records, which is the premier record label for both Otter and database-related hip hop music.
New album from DGOT is coming out next month.
Awesome.
Yeah, I would say also too, databaseology is not a real thing. I just call myself that, and like the university thinks it's real. So anytime I go to events like neurology or ecology, they print it out as databaseology.
Yeah, it's perfect.
Yes.
And then Jordan, thanks for also joining us, is the founder and CEO of Motherduck, which is a startup focused on DuckDB, the wildly popular now in process SQL OLAP database management system. Prior to founding Motherduck, Jordan was the chief product officer at SingleStore, and then was on the founding team, leading both engineering and product management at BigQuery for Google for many years. I'd definitely say check out a recent blog Jordan published titled "Big Data is Dead," which really sheds light on the overkill, I'd say, of a lot of OLAP systems for basically 99% of the world's data. So Jordan, thanks for joining us as well. You're still on mute.
Muted.
Sorry, I couldn't unmute myself.
No worries. So
thanks, great to be here.
Thanks, Jordan. So maybe to kick off, I think what we're going to try to do, the title of this talk was really just about the various components of modern OLAP systems and the sandwich stack of the layers. So when we think about OLAP, it's everything from the file format itself to the storage media to the storage engine, table format, metadata management, execution engine, computation query engine, and query optimizer. So I think, Andy, Jordan, the way to start to think about this is maybe kind of per layer. What have you seen as the macro technical trends that have really led us to what the current state of affairs is within kind of critical layers? And maybe as we kind of go layer by layer, talking about, what's best of breed that a user who's either kind of building an OLAP system in-house in a large enterprise or even thinking about building a database management system themselves is they could just grab, it works off the shelf versus where you think innovation really needs to kind of happen within various layers. So maybe, Andy, I'll start off with you, just kind of thinking through the stack and providing some context.
Right. So I think if we just start at the bottom, the data system would be like the storage layer. And, with Snowflake, BigQuery, and, these other cloud-based systems, everyone has switched these large-scale distributed database systems for analytics to a shared disk architecture. So shared disk would be every compute node can access the same sort of shared disk layer. So like S3, the Azure Blob Storage, and then I think GCS is what it's called. And prior to that, the conventional wisdom of how you build a scalable distributed OLAP system would be a shared nothing system where every compute node has its own local disk, which is like a shard or partition of the total amount of data, and you have to sort of move things around accordingly. So Snowflake was the big game changer, and they rode the wave of Amazon and the cloud and taking advantage of it. So that's considered the state of the art now. If you're going to build a new OLAP system today, you'd want to run off S3 or whatever object store your cloud provider provides, because it's one less thing you have to worry about. You don't have to worry about building up the storage layer, don't have to worry about durability and all that. The cloud vendor takes care of that for you. It does make, it could be potentially more inefficient for running queries because you have to pull data off S3 into your compute nodes. But there's I think the genie's out of the bottle and we're not going back to a different architecture. So my opinion, is to start at the storage layer and then turn it over to Jordan. S3 is the state of the art, or something like S3. And I don't see anybody building, again, a large scale system today where you'd want to bring on the responsibility of managing storage at that scale. And so that means really the only innovation you can really have and if you're not controlling the compute layer, or sorry, not controlling the storage layer, is on the client side, of the driver side of the database system. And so how fast can you get things off of S3 or whatever into your local compute nodes? And the only thing I've sort of seen has been sort of fascinating in this space, not fascinating, but interesting. I think Yellow Brick, those guys basically rewrote their own S3 drivers and try to get things in and out through kernel bypass as quickly as possible from S3 into the compute layer. That's pretty much all you can do. S3 exposes select commands. You can do predicate pushdown. I don't know how many systems actually take advantage of that. I know Redshift does, but outside of them, I don't know who else.
Yeah, I mean, so maybe just a comment on the storage layer. This was sort of the area that I worked on in BigQuery. I designed like the original BigQuery storage system, helped it scale. It got up to about an exabyte of data before it started getting creaky, and the people that knew how to build systems at scale could step in and fix some of the initial problems. But an exabyte of data was something like 8 orders of magnitude larger than we thought we were going to need at the beginning. So it wasn't so bad. And so like I'm very like I used to say like the most interesting parts of databases were the storage systems, or at least the most like the biggest opportunities for real innovation, because it seems like if you want to have like 10x improvement, by building a better optimizer, maybe you'll be able to have like a handful of queries that are faster, but there's just sort of like there's no magic beans. And but if you can have a better way of storing the data, read less, so that you can read less data, move less data around, like especially in large scale systems, IO is still a big bottleneck. And even if it isn't like by kind of immediately reducing the size of data that you need to operate on is a big opportunity. So I think this is an area where I do differ a little bit. I mean, I think you're right that like S3 is sort of the state of the art of like, yeah, everything gets stored on object store. And that puts its own sets of constraints on what you're doing. For example, object stores are immutable. And so that means that once you kind of finish writing an object, you can't go in and like change row 37. Turns out that works, reasonably well on column stores, because column stores, you can't really go in and change row 37 anyway, but it also just constrains, what you can do. And I think that I think where we're heading towards because of this is actually sort of a I get maybe it's a local optimum, but like in general, like there's we're kind of missing out on a lot of potential innovation because we're sort of saying, okay, well, we're standardizing on files that have to sit on S3, and there's a bunch of other interesting stuff that you can't do. And I won't go too far down that path just yet, but that is something that I would like to chat about.
I mean, can you click down a little bit about the file format choices and kind of how that interplays with the object storage and frankly the storage engine on top as well?
Just real quick, I agree with Jordan. We'll get to the file formats next, but like is S3 the best? There could be no, but there's so much inertia behind it, and people are just putting a ton of data along. And so if you're going to be a new database company today, or even one of the existing ones, to come along and say, no, you need to move all your stuff that you have in S3, Parquet files, org files, we'll get that in a second, and switch to my other proprietary thing. That's a major ask, and I don't see anybody can bend the world that way.
But I think as is one of the sort of the truisms in software engineering is like, anytime you run into a problem, you just add another layer of abstraction. And I think what a lot of folks are doing is they add a layer of like SSD memory on top of SSD, just because the final storage, the final resting place of the data is on S3 doesn't necessarily mean what you're doing has to incorporate all of the characteristics of S3. And I think if you like the cheap way of doing it is, okay, well, you just, basically you write all the way through to S3. But there's also some interesting things that you can do with, if you commit to, things that have enough durability, you may be able to get much better performance. The problem about that is then you need a global coordinator, and you need, because like if I'm writing to, like, let's say I'm writing to like 2 copies of memory and I'm writing a write-ahead log on an SSD somewhere, and then eventually flush that out to S3. You can't just have a client that only is looking at S3 or that's coming in from somewhere else, which kind of obviates some of the sort of lakehouse architectures that people are building. So, already sort of we're kind of considering our design space if we have to sort of operate within sort of the lake houses as they're currently being built. And I realize I'm, perhaps throwing out some, potential, areas for spicy topics.
Mm-hmm. Yeah, so we could certainly get to the table formats, which is, there's just a lot of activity happening on within the lakehouse architecture, but maybe Jordan, click down a little bit about the file formats themselves, because I know we spoke about that yesterday. Yeah,
so just a couple of interesting data points is like, so the 2 database companies that I worked at, the teams that were designing the file formats were not the storage teams. They were, BigQuery was using a capacitor format, and that was designed by the execution team. And in SingleStore, the storage team was also not doing the internal SingleStore data format. I think one of the reasons is if you really want strong performance, the storage format is really a reflection of the data structures that you're using to query. And basically, because you don't want to pull the data out and then have to marshal it around and then rewrite it. Like a lot of the benefit is sort of leaving the data, as much of the data as possible, in place. And so I think that kind of by tying tying the storage format to basically say this is treating that as just storage, it means that it also constrains your ability to build a great execution engine. And I think, Parquet, I think is another example of like, Parquet is certainly winning the format wars, but Parquet is really kind of a 15-year-old technology that I think they've tried to improve. They tried to make improvements, but the problem about standardizing on file formats as your method of interchange rather than like as something higher level means that it becomes very, very hard to change those. And so that also hampers the ability of query engines to really build fast queries over the data because they don't actually have any control over how the data is stored. I know, Andy, what are your thoughts on the topic?
I mean, so Parquet and Orc are 10 years old. They were developed, obviously coming from the HDFS world. The development at a different time, I think hardware has changed. And in particular, the trade-off between network and CPU has shifted. No offense to Nick, because he's at Intel, but network has gotten a lot faster and CPUs not so much. And so the idea that you'd want to use like an off-the-shelf compression algorithm like Z-Standard or something for the blocks you're reading, if your network is really fast, that doesn't make sense anymore because the CPU cost of then decompressing it doesn't work. There's other issues that Jordan brought up, where again, if someone has designed a file format and is maybe not cognizant of what the full system looks like, there are certain design decisions they make that are they don't realize until it's too late. So, and in particular, I'm thinking like in Parquet and Orc, they don't expose the dictionary for decompression. And the Priscilla paper from YouTube for their file format for their engine pointed this out. Like they fixed this. So we're now 10 years into this, and this is still not something that Parquet can deal with. an org can help with. So I think there's time to go revisit this. I don't know what it's going to be. I have a line of research with a former student of mine looking at what a more ideal file format for modern cloud systems should look like. There's also in the Velox paper that came out this year, they mentioned Facebook or Meta is building the new alpha file format that addresses some of these problems as well. So I think there's going to be a new version of Parquet that's going to be, again, designed for a modern era. Arrow is for in-memory transfers between processes or over the network, but we're really talking about the archival files, things that data at rest.
Jordan, I think one question though is ultimately you have to design a system for a trade-off between depth and breadth at the end of the day. And you have legacy file formats, you have an explosion of execution query engines. And it sounds like really to best optimize things, there would be a tight coupling between the query optimizer, the query engine, computational, and your execution engine for the workload on top of it. But I mean, it becomes somewhat narrow and challenging. And so, I mean, it seems like that benefit will be a balancing act and somewhat tied to the execution engine. So maybe it's a good transition, Andy, to talking about at least Velox and some of the attempt to standardize the execution engines behind the proliferation of query engines out there right now.
Yeah, and I think there was I made this comment. I know others have said something similar in the last year, and there's sort of the catalyst of having this panel. I think that there's a lot of money being thrown at these new database companies that are all kind of building the same thing, like a vectorized engine, query engine that runs on top of object stores. And I don't see a lot of innovation in these particular systems, and they're all basically implementing the same thing. And so Velox comes along. There's also Polars. There's the Data Fusion project where people are trying to build these sort of just the execution engine layer, and then that they can, and then it's extensible enough that you could apply to different sort of problem domains. And I think this is a good idea because when you look at the history of where we're at right now, like the original sort of vectorized execution engine paper was from the CWI guys, the precursor to DuckDB, or VectorWise. That came out 18 years ago. Snowflake was 10 years ago. AVX 512 was what, 5, 6, 7 years ago. So like the research has solidified, like this, we know how to build a high performance vectorized query engine. And so rather than everyone just reinventing the wheel, I think having a sort of common system that people could leverage and use is the right thing. Now, to Jordan's point, you absolutely need to be aware of what's above you and below you when you build a system. And I haven't worked with Velox to know that like it can handle all possible things. That is my understanding of the goal, what they're trying to do, and this is what Facebook is claiming that they can do. But my main take is like, if you want to build a new database system today, Velox would be a good starting point, or potentially Data Fusion as well, or Polars. Next best step would be taking like DuckDB or ClickHouse and hacking that up. But just saying today, I'm going to write a brand new OLAP vectorized database engine from scratch, it seems like a wasted effort.
Would you speak a little bit, Andy, just for the audience of maybe at a more granular level of task handling, what the line is between a computation engine and the execution engine, and frankly, the storage engine underneath as well? Like who's handling what from a workload perspective?
I mean, the giant umbrella is this is the database system, right?
Yeah.
We would take ownership of all of that. But like Velox would get, my understanding is Velox gives you the implementation of the physical operators in a query plan. So the scans, joins, aggregations, and so forth. I think they have connectors to read data from different data sources. They might have ability to parse like CSV files or Parquet files and read them in to whatever the internal format is. But they don't, as far as I know, they're not responsible for actually going out to S3 and getting the data. Okay. And then if you bring it in to like, where do you actually store it? Is it sitting in your in-memory buffer pool? Are you storing it in like a locally attached SSD as a cache? All right, how do you send data between nodes if you start doing shuffles? Velox doesn't handle that. So that's sort of, you'd have to build additional infrastructure around that. But that, again, we know how to do this. This is not like, it's not very challenging anymore. I would say, building leveraging AVX 512 in an efficient manner in the right way, that's harder than, you know, sending things over the network. So like, I think you could build basically the scaffolding around Velox to be able to, you know, get data in, process it, and then send queries out. Now, how do you actually get the physical plan? That's a whole other part we'll get to eventually. But I think that's even the hardest part. But my whole take is like, okay, rather than just everyone trying to build a new system from scratch to become the next Snowflake, Yellowbrick is doing this. There's Oxient out of Chicago. There's still people like, even today, there's money being thrown at companies trying to build a new OLAP engine, and I think that's it's an uphill battle, and you just leverage just leverage Velox or Data Fusion.
So before I started working on databases, I considered myself a compiler person, and I like metaphors or analogies, and I feel like there's an analogy with kind of what happened in compilers with for a long time people were reinventing the wheel with compilers, and they're like, okay, well, the compiler front end and back end and mid IRs, et cetera. Like, everybody kept reinventing those things. So why don't we build, just sort of one, general purpose thing that will work, and then we can, generate compilers, like a compiler generator that can work for all sorts of different compilers. And this was sort of like the mythical, like, white whale of compilers. I was at Microsoft when we tried to build one. I think it was the Phoenix project, and spent a lot of time on it. It didn't quite work out, live up to its goals. It did some cool things, so it wasn't entirely a failure. But then LLVM came along, and seems like now you'd be silly to kind of reinvent a compiler yourself when you can just use LLVM and like target to their IR, and then you can generate code for any platform. And it does seem like we may be getting to a time in databases where it's sort of the same way. And so maybe Velox is the LLVM. Maybe it's the Phoenix project. Maybe it's, like, who knows? Like, I think it's a little bit early days to sort of like say that, nobody has to build a database anymore because of LLVM.
Execution engine, very clear. Execution engine, not still need other stuff.
And if I understand your premise, everyone should use S3. File formats can maintain consistency. Use Velox, and the magic's in the query engine itself and in the query optimizer.
Correct, but again, I'll be very clear. I'm not saying like, is S3 the best that we could have? No, but it is what it is. Like, should we be on the metric system? Yes, but we're stuck with foots and inches and pounds, right? Like, and does that stifle innovation? Sure. Yes, I agree. And to Jordan's point, at the end of the day, like, if you're just reading, orders of magnitude more data from disk than you need to, because you have to, like you want that to be fast as possible.
Yeah.
Does that, like, I mean, so in a world where kind of, you're building these components, does that mean we sort of have like a regression to the mean? Like, is basically like you mentioned like there's a bunch of these kind of query engines that can query data lake engines, or they can query data that sits in your data lake. At some point though, do they become indistinguishable?
Oh yeah, absolutely, yes. It becomes a commodity. And so my point is, like, unless Nick can tell us, but he probably can't, like, I don't see any magic hardware coming on the horizon at the computational level that's going to require us to completely rethink how we build OLAP engines, execution engines. It's going to be SIMD, it's going to be vectorization. Yeah, we get more CPU caches, maybe get more cores, but there isn't some magic hardware that's going to come along. It's not going to be FPGAs, it's not going to be GPUs, maybe some kind of accelerator down on RISC-V, but that's a decade away at that, right? Like, there isn't anything in the near future that is going to require us to throw away all the literature and start building these engines from scratch. So my take on this is like, okay, rather than build that piece that that everyone knows how to build, because Snowflake did it 10 years ago. I teach this in my class on how to do it. Take something off the shelf, use that, and then focus on the other problems that are unsolved.
And I think to me that's actually where interesting, because I think for so long, database companies have been competing on performance. And kind of if you kind of iterate out like all these database companies, there are no magic beans. There's, kind of, optimizers, and perhaps this is an overly reductive view of optimizers. Optimizers are kind of a bag of tricks. Kind of every once in a while, eventually, kind of everybody implements all the tricks, and things, things tend to sort of all trend towards the same level of performance. But there was something that you said the other day, Andy, which was like, really kind of where you can differentiate is on user experience and usability. And, I think that could be really the next kind of wave of database, or the next frontier. If you think about like, I worked for a database company. I won't name them, but, they're incredibly fast, but they require a lot of work to like how you place your data and how you design your schemas. And so you can't always get the benefit of that without like being willing to like do all this extra work. And, I think if there's a way that you can sort of make it simpler, to get good performance. So there's one way of kind of improved user experience, but then also just sort of making sure that, simplicity of like, of what you're providing, and then also innovating on what you can do in the cloud. And I think that's an area where I don't think we've entirely explored all the options.
Yeah. And Alex, I see your question. We'll definitely, I promise, get to it and open up. I mean, there's definitely been innovations within underlying hardware the past 10 years. I'd predominantly say a lot of the speeds and feeds, Jordan's, came from innovation within IO and within memory and caching, as far as avoiding data hops up and down the layer of the stack. Less, there's certainly been performance gains from core work around dropping down nanometers within, but it's really the network.
There's so many things you can do to speed up OLAP systems, right? You either read less data because you have an index or filter, or you have something pre-computed like materialized view, or the data you do have to read, you just try to make it smaller when you bring it in, right? And so at the end of the day, as you said, these are standard bags of tricks that people know how to do. And my whole thing is like, you don't need to reinvent the wheel. Use something off the shelf that already kind of does these things. I disagree with his comment that like there's a standard bag of tricks that everyone does in the query optimizer. I think that's ripe for innovation. It's super hard, super challenging. SQL Server has the best, in my opinion, query optimizer in the world. Even it chokes on a bunch of stuff. DuckDB is actually very good, but their cost model is not good. They don't do sampling like SQL Server does. So there's a lot of stuff that can be done. And if anything else too, this is where machine learning can help, because it's a lot of like learning from what didn't work from the last time and applying that to decisions in the future. So to Jordan's point, user experience, how quickly can you get, help people get on board, get the data in and manage the thing for them. But then also how well can you generate query plans? Because that's going to be, because like I said, there's no magic hardware coming that's going to get you another 10x or 100x the way like we went from a row store to a column store. That ship has sailed. So where's the next improvement going to come from? And it's only through query optimizer.
Speak a little bit. I mean, query optimization is not a new space. People have been working and thinking about this problem for a long time.
Yes.
What do you think has changed beyond the advent of like applied machine learning? The challenge is like you can optimize a query, but the workloads are not static. There's many different variables that drive into it, and so it's certainly like an evolving landscape from the application logic on top, and for OLTP, and then for OLAP, like the reads, writes consistency, frankly queries themselves, the timing of them. There's just a lot of variables. So like, what has changed now? Why do you think there could be breakthroughs?
I don't know. I don't know if there will be breakthroughs. Right? It's because it's an NP complete problem. I don't think there's any magic you can do. I think that, and certainly actually going to the cloud, it makes it even harder because your cost models are garbage. Because if someone shows up a bunch of data sitting on S3, even if you then cache them in EBS, you may not actually know what's in them. So the query plan if you choose like a cost-based search, maybe it's actually terrible when you actually start running it. So there's a lot of work done in the late 90s, early 2000s on adaptive query optimization, meaning like I pick a query plan, I start running it, and then I realize I made bad decisions, and can I adjust it? The most simplest form is to say, stop what you're doing, go back and get a new plan with updating some stats with what you saw. IBM had something like this in the early 2000s. Snowflake can do a little bit of some of this, as well as I think Databricks. I don't know what BigQuery actually does, so Jordan can fill me in. Like,
yeah, BigQuery does dynamic execution. So we start with the simplest query plan. We start like broadcast joins. We start with like kind of single node aggregations, and then kind of hit a tripping point, and then it flips. The problem is that that means if you don't do the upfront work, and it means that it's hard to get low latency queries if the query the optimal query plan isn't the one you picked in the beginning, because you end up like, no matter what, you're going to have to do some work unnecessarily.
Yeah. Right. So getting the right join order is super hard. That's one of the biggest, if not that is the biggest challenge in query optimization. And it's a paper from the Germans from a few years ago about analyzing the cost model estimations from time budget for systems, and they're all terrible. The SQL Server is the least terrible. And then as you add more joins, it's the Wild West. Everything gets wrong. So there's been a line of work in trying to use machine learning to predict the cardinalities better, which again is something that I think this is where I think machine learning could actually help, because the way we're doing estimations now, it's all derived by human statistics and summarizations and sketches, right? It's a human is implementing these things, but there may be correlations and other patterns and other things that are just hidden that we don't find, but the machine learning stuff can pick it up. But again, you need training data for that, and that's super hard if you have a bunch of data that's sitting on S3 that you haven't looked at in a year. So I'm not saying it's a magic bullet, but like I think that would have the most opportunity for in this space. And this is public. Redshift bought a team out of MIT to start building this kind of stuff into their engine.
Yeah. So how much opportunity do you think there really is in an optimizer? Like, if you could make optimizers like perfect Oracle, is it going to make queries in general 2x faster, 10x faster, 100x?
I think it's 10x. But I mean, it's for simple things, sure, you're not going to see any difference. But for the tail's long, because there's a lot of queries at scale. And I think, as I said, once you go past like 5 tables in a join, the stats are just a wreck. And so I think I think there's 10x. Can't prove it, but I think there is.
But how often do you have 5 tables in a join?
You have those numbers. I don't know. I mean, it's a long tail, but there's enough of them that
sure.
they would matter.
Yeah, no, that makes sense.
Why don't we, I think Alex in the chat will, when we open up a second, talk about too, data sparsity and the long tail becomes a big challenge. Let's wrap up a little bit with what's going on metadata management, access, many reads writes, handling ACID principles within an OLAP system, for lack of a better term. Jordan, do you want to maybe kind of start off, because there's between Hoodie and Iceberg and Delta, it's a lot of activity, for lack of a better term, in the ecosystem right now around lakehouse architectures.
Yeah, and I think this is an area where we may end up in a kind of a local maxima of we can, because of how we've designed these lakehouse systems, that there's a lot of innovation that can't be realized, and metadata is one of the harder problems. Like, the more metadata you have, which includes like query statistics, it includes kind of information about which blocks are where, then the better you can do with reading less data. And if you can read a lot less data, you can make your queries a lot faster. But one of the problems with sort of how we've designed some of these systems is all of the metadata has to be persisted on S3. And when you persist all that data on S3, it means that you can't do that pruning, you can't do those updates nearly as fast. It's why sort of in Snowflake's Iceberg implementation, like they basically copy all that metadata out, and then they use their own metadata system. Like, if I was gonna build the next version of those systems, I would basically create a server that, that actually owned the metadata. And every time, but it would mean that every time you wanted to read the data, you had to actually go to the server to understand that. But that lets you do much faster updates because it can sort of point you at the data that you need. And also, once you have that server, you can then do interesting things on the sort of the coalesce and compaction. Because one of the things that happens in a real world data set is that the data set's being updated. You're adding new rows all the time. And over time, the data gets a lot more difficult to query. You lose locality, so you have to rewrite those files, and so lakehouse systems tend to try to rewrite those files either kind of like as a side effect of eventually they'll do that when you're writing, or sometimes they'll do it on the read side. And that has sort of like both of those have their own kind of downsides. Whereas if you have actually a server that owns the data, owns the metadata, it's a lot easier to have have better control over how you're representing the storage system. So I realize it's a little bit like kind of esoteric way of describing the world, but also it feels like we are missing out on some opportunities here.
I don't have any strong opinions about Hoodie versus Duzleg and so forth. I just know that Hive Store was not what people should be using. So getting people off of that is that's again, you're bleeding out. So we patch that, then we got rid of the meta store. We can look at the next thing. But I've seen the numbers of people saying why they had to switch to Iceberg, whatever. The size of the metadata was so massive that it took forever to do lookups. So I think this space is still early. I haven't looking at them. I don't see anybody doing anything. Oh, this is stupid. You would not do it this way.
Yeah. All right, guys. Well, let's just open it up for questions. And if anyone in the audience has a question, just use the raise hand button. Alex, I'm just going to unmute you, just given I know you had some. If you want to jump in.
So I feel yeah, okay, sure, I'll ask a question. So I was curious to hear more about the ML stuff. I know we kind of touched on it before, but my intuition for generally I feel like we've had a really hard time operationalizing machine learning in compilers. And in some sense, I think those optimizations there's a class of those optimizations that appear to be, from the outside, not an expert, a lot simpler than the sorts of optimizations that you would have in a database, because it seems to me that one of the defining operating characteristics of OLTP databases is that you get predictable, reliable performance on certain query execution plans after you do the optimization. And when you look at the set of things that you would have to optimize on, you have this enormously sparse space, this just enormous number of things that could factor into a reasonable optimization decision. And when you're trying to build machine learning systems, usually if a space is really sparse, it means that individual things that you're capturing are generally not important. That's what sparsity means in a model. It just seems like it would be we have arguably not even solved anomaly detection for online services, and it just seems like a really long road to get machine learning to be operationalized in the context of an OLTP system.
Right.
I don't really have I didn't have a clear articulation of this question. I was just that is I would love to hear more about why you think about that, just because
you're skeptical that you would want to use ML to optimize OLTP queries. And
or at least not in a way that totally replaces the query optimizer, right? I think that would be
two things. Yeah. So one is most of the queries in OLTP systems are sargeable. Exactly what index I should have. If you don't have the index, the query optimizer is not going to help you, because then you're falling back to a sequential scan. So there's a separate problem which we can use machine learning to do, and we do this at OtterTune, to say what index am I missing, or what do I need to do, and that's independent of the optimizer. Now, so assuming you have the index, you know what index to do lookup. Now, there are some like 2-3 table joins and OTP workloads and things can go awry. And in that case, again, don't think of machine learning as the thing that's like deciding the join order. Think of like training models to do cardinality estimations. And again, I would argue that the research shows that is way more accurate and more and better and more robust than handwritten sketches and summarizations and histograms. So for OTP, I agree with you that you got to be careful. And I'm not saying you remove all of the histogram stuff or the existing stuff, because obviously if the model is insufficiently trained, you want to fall back to something, right? For OLAP, I would argue it's going to have an even more bigger impact, and I would be more aggressive in this than adding this because it's the bar is so low. That's my dog has allergies. The bar is so low, and I think it would make a huge difference.
Yeah, if I could just second that, I think I think one of the things you may be referring to is like there was a paper on learned indexes. And I think people have been sort of like looking at that and like, hey, this seems like really cool. We could do learned indexes. But I think for some of the reasons that you bring up, like that ends up not being as effective as you'd want in a real system. But I think, just to highlight what Andy was saying, like if you can do better cardinality estimation, and if you can do cardinality estimations when you have like, predicates that say, hey, there's a filter here that says, where blah, blah is 3, is that going to be, one row or a million rows? And I think, machine learning can, like right now we have just sort of bad heuristics about that. And, but machine learning can make those bad heuristics better. And I don't think they're going to be significantly regressing us from the bad heuristics. And in some cases they can make it a lot better.
That makes a lot of sense. Thanks for the insight.
Sure.
Any other questions from anyone in the audience?
You guys want to raise your hand?
Raise your hand or just type something in the chat and I'll unmute you.
Andy, do you have any really spicy takes that we can would use to prevent us from being able to make this recording public?
Other than he's net short all new database companies.
Wait, you said a what?
I said other than you're net short all new database companies.
I mean, is there actually a database company that went public that is profitable at this point? I don't think Mongo is. Snowflake isn't. Splunk isn't. So again, I would say there's a Gartner report, and I agree with them. A bunch of these database startups, as much as I love database systems and new systems and learning about them, they're going to go under because they've raised a ton of money and really high valuations, and then there's only so many that can proceed to go IPO, right? So at some point, the money's going to dry up because they're going to need even more, and they're just going to get destroyed. And then what happens to them? Well, at those crazy high valuations, who's going to buy them? Google? Well, no, because they have BigQuery. Amazon? No, right? So I just don't see. I don't want to name names, but there's a bunch of them who raised a lot of money. Snowflake can turn to gross profit at any moment. The gross margin is sure. But, all right. What about? But they haven't. There's Mongo. Anyway. Sorry, they're claiming, he's also claiming about Amazon bought Parcel, but that was 10 years ago, right? When they made Redshift. The cat's out of the bag. They have a mature system that's competitive. Like, why would they buy ClickHouse, for example, right? For the customer base? No, they already make way more money. So I think a bunch of these companies are going to go under. And I think you saw the churn, the late 2010s with all the NoSQL companies. Like Basho went under, Rethink DB went under, right? Because they're all trying to become the next Mongo, and a bunch of them are sort of, kind of in like zombie maintenance mode. And so, unless they're like, for these companies, these startups, like unless they have like one big customer that needs to keep them alive, that's going to buy them, but I don't see them paying billions of dollars to maintain whatever system they're using when they just use the money to switch over to Redshift or BigQuery or something else. So if I was a VC now, I would not invest in someone claims I'm going to be the next Snowflake. I think that's a bad bet at this point.
Love it.
Yeah, well, that's just like your opinion, man.
on Exxon and on Lebowski. Jordan and Andy, thank you.
I'd say also too, don't bet against the relational model.
Don't bet against Excel. Don't bet against free distribution. Andy, Jordan, thank you so much for taking the time this morning. I really appreciate it.
Yeah, well, thanks for organizing, and great to chat with you, Andy.
Yep.
All right.
Thanks, everybody. Bye.